So in chapter 9, you're going to continue looking at situations where you have transformations of functions to make new functions, except now, before when we just looked at vertical transformations, we're going to be working in some horizontal transformations. You see the shifted right 5 units. Horizontal transformations are a little tricky, which is why they had you practice the vertical ones first, and now they're giving you these. The reason that they're doing this is that you're going to start working with quadratic functions, and some of the features you're going to notice about it is going to involve some horizontal transformations from the typical quadratic function. So looking at this instance here, you have the exponential function f of x equals 3 to the x power. The function g of x is the result of performing the following transformations on f of x, and there they are here. It's compressed vertically by a factor of 1/2. It's shifted right 5 units. The function is then shifted down 8 units. Write the equation of the function g of x. So it's going to be something that has a 3 to some power of x in it, but there might be other numbers being multiplied, added, subtracted, divided in different places, and we'll have to account for those as we do it. For the time being, though, I'm going to define g of x as being a transformation of f of x. So we'll start with f of x here. And we have the two vertical transformations, which are things we have dealt with before. Compressed vertically by a factor of 1/2 means it's going to be multiplied by 1/2. That means the function itself, or the y values, if you will. The function is then shifted down 8 units, means that you're going to subtract 8 from those y values. So basically what's going to be the result of these two is that you're going to be multiplying the function by 1/2, and you're going to be subtracting 8 from the function. Now, horizontal transformations are going to define what goes on inside these parentheses, whether it's in f of x form, or in this case, what's going to go on in the exponent. And right now you see that the function is shifted right 5 units. Well, if you shift right 5 units, that means you would be adding 5 to the x values. And so here comes the first thing that you have to be aware of with horizontal transformations. Whenever you indicate a horizontal transformation in a function, you're going to write the opposite of what you want it to do. Here we want it to add 5 to the x, so as a result, we're going to write in here subtract 5. And so that's one of the things that gives some students issues with horizontal transformations, that you do the opposite of what it asks you to do, as far as what you see in the function. Now, as far as that goes, that would be the result of having the transformations due to this, but keep in mind you want to put it in terms of this. So f of x minus 5 would just be this thing here with x replaced with the x minus 5 in the exponent. So the actual function you want for this is 1/2 times 3 to the x minus 5 power minus 8. So when you're given a definite function as what was known oftentimes as the parent function, you want to make sure that this resulting function has a similar look to it. So I should see this exponential base of 3. I should just see all these transformations defined here associated with them in the right places. It gets even more complicated when you have multiple horizontal transformations. So here you have the function g of x is the result of performing the following transformations on f of x. So f of x this is going to be just written in terms of f of x here. F of x is stretched vertically by a factor of 3, then shifted up 5 units. So those are your vertical transformations. The function is shifted left 2 units, then reflected across the y-axis. One of the things you have to get used to is here the stretching occurred first and then the shifting, because stretching means you're multiplying by 3. Shifting means that you're adding or subtracting. And that is what the order of operations would have you do. That's the order you would do them in. When you do multiple horizontal transformations, the way they're typically done is that any shifts are done first. So any additions or subtractions are done first to the x value, and then it's multiplied or divided by something. So you're often going to see that when you have a description, the shifting for horizontal transformations is done first, and then anything that requires a multiplication, like this is a reflection of across the y-axis, That means you're going to be multiplying by a -1 somewhere. That's going to happen second. And you have to be aware of that whenever you're making the function up here. So starting with f of x, the vertical transformations are pretty straightforward. It's stretched vertically by a factor of 3, then shifted up 5 units. So you're going to be multiplying the y values by 3, and then adding 5, which means that you're going to be multiplying f of x by 3 and adding 5 to it. So you're going to have a multiplication of 3 here, a plus 5 here. So now for both of these, the function is shifted left 2 units, then reflected across the y-axis. These are horizontal transformations, and we've done one in the previous example where there was only one. Now there's two. And that complicates things a little bit because first notice that it's shifting left 2 units and then reflecting across the y-axis. That's the order in which the things are going to occur in the transformations. However, inside the parentheses, which is where the horizontal transformations will occur, you have to do everything in reverse. And so here you're doing the shifting left, which is usually going to be at a subtraction of 2, and then you're reflecting across the y-axis, which is going to be typically a multiplication of -1. Notice it's listing them in the opposite order than you would normally do them with the order of operations. So you're seeing here that the horizontal transformations are applying. It's going to subtract 2 from the x-coordinates and then multiply by -1. Again, that goes against the order of operations. Also, along with that, when you say subtract 2, you're going to show in here at some point an addition of 2. And then the multiplication by -1 is going to indicate you should divide by -1, which here, if you multiply by -1 again, it's going to do the same thing. It's just going to make the x-coordinates negative. The difficult part is inside the parentheses here, if that's the order you want them to occur, you're going to have to apply these in the reverse order than what they're listed. And so what's going to happen up here is that the reflection is going to happen first, so you're going to divide by that -1 first, and then you're going to add the 2 to make the x's be subtracted by 2. So it's a little confusing in that nature because of that. And so if you follow these in order, dividing by -1 is just going to put a negative in front of the x, and then adding by 2 means you're going to add 2 after that. And so that's the expression. You're going to have 3 times f of -x plus 2 plus 5 being the function you need to have in here. And so that is the end of this problem and this video. If you have any additional questions, please bring them up during class.